What we're going to be doing with polynomials today is we are going to be taking a look at using the calculator to answer all the questions, because for this particular example, notice we are not in factored form like we were yesterday. Okay, so this is in standard form, and in this in particular, because of the irrational coefficients, it's not something that we're really able to factor either. So this box up here is just a review. The x-intercepts, you're using the 0 feature, and for the turning points, you're using the max and min feature. So we'll be using all that and answering questions about polynomials. So hopefully you guys have this in already. What I'm going to have you do is go ahead and press Zoom 6 so that we are all in the same viewing window. And then you should end up with this polynomial. Now, what is the degree of this polynomial? I'm sorry? The degree is 3, and because the degree is 3, what is the maximum amount of turning points we could possibly have? We can only have 2. So we actually have the maximum amount for this particular polynomial. What I want you guys to do is go ahead and make a sketch of the graph over here. And it looks like this intercept is just a little past -2, so I'm going to put -2 to the right. And I'm just going to put a point just beyond that. And then this intercept looks like it's close to the halfway point, close to 0.5, maybe a little bit more. So I'm going to kind of put it right here. And the last intercept looks like it's just a little bit past 2. So I'm going to put that right here. Okay, and then I'm not so concerned with the rest of it. So I'm going to go ahead and just draw the sketch. What is the power function for this polynomial? What's the power function? I'll give you a hint. It's always the leading term. The whole leading term. 1x to the third. 1x to the third. So you're going to have the coefficient and the whole first term. Now yesterday we had this in factored form, so we had to pay attention to what the leading coefficient could be, and then we had to figure out x to what power. For this one, we can see what the leading term is, so we don't have to worry about trying to multiply it out or looking at the multiplicity. It's just actually given to you. All right. So then what we want to do is we want to find the x-intercepts. So finding the x-intercepts, what feature are we using? We go to second trace, and to find the x-intercepts, we're going to use the 0. So I come over here to 0. And I know that this is around -2 here, so what would be an easy left bound? -3, and what is to the right of -2? -1. So then we're left with -2.16, 0. Why don't you guys go ahead and try to find the other two on your own? And when you're done, go ahead and look up and check. And what I'm going to do really quick is I'm just going to put these values of x right on the number line here. So -2.16, +0.8, and then +2.16. All right, what's the easiest way to find the y-intercept? Yeah, if you look at the equation, what are we going to do? Plug in 0 for x, and it's awesome for when it's in standard form because what is the intercept going to be then? Yeah, just the constant term here. So we're going to get when x is 0, the intercept is 3.73248, and you're good to go. Okay, so the next part we want to do is we want to determine the intervals of the graph that are above the x-axis. Okay, so we're trying to really find when is y positive. All right, easiest way to do that is to come over to your graph and actually draw a sketch here and shade all the parts where it's above the graph. Now, when we describe this, are we going to be using x to describe it or y? We need to use the x to describe it because really from 0 to infinity we have values of y that are positive, so it doesn't make sense to say 0 to infinity because y isn't positive everywhere. Like here y isn't positive, so 0 to infinity wouldn't make sense there. So what we're going to do is we're going to use x to describe it, and luckily we have our intercepts already. All right, and that's where y is already equals 0, so we're going to use these x values to describe it. So for when it's above the x-axis, we're starting here at negative 2.16, and we're going all the way to 0.8. And then union, and what is our other interval where it's going to be positive? 2.16 to infinity. For here, it says when it's above the x-axis, so it's not when it equals 0. So you would definitely need to use parentheses there. All right, why don't you guys see if you can write the two intervals for below on your own, and then when you're done, look up and check. All right, anybody have questions? Okay, for the turning points, we're going to come back to our calculator, and we're going to press second trace. What are we using here to find the turning points again? Maximum and minimum. So is this a maximum here or a minimum?
Maximum. Oh, yeah.
This is a maximum. And then this guy here is a minimum. So we are trying to find the turning point. So we're trying to find both x and y values. So I'm going to start with the maximum. And it looks like it's close to what number value for x? It looks like it's close to -1. Good. So for left bound, I'm going to use -2, and for right bound, I'm going to use 0. And then we end up with, for the first turning point, we end up with -1.009, comma 6.598. Okay, so then second trace. What are we going to use for the other turning point? Minimum. And it looks like it is just a little shy of 2. So I'm going to just have my left bound be 1 and my right bound be 3. So my other turning point is a 1.542 and -1.6 9, 8. And what I'm going to do is I'm going to go ahead and put the x value here, so I get negative 1.009, and then here I have 1.542. Okay. So what we want to do next is we want to talk about when the function is increasing and decreasing. All right, well, the function is going to be increasing and decreasing between all the turning points. So we're starting from left to right, and if I'm starting here at negative infinity, am I starting by increasing or decreasing here? I'm increasing, so I'm starting at negative infinity, and I'm increasing until what x value? Negative 1.009. And then starting at negative 1.009, what am I now doing? Decreasing. So I'm going to come over here, negative 1.009, and how long are we decreasing until? Good. 1.542. And once I hit 1.542, what are we doing now? Increasing. So I'm going to come back to increasing. Union. So I have 1.542 until infinity. So it's unbounded increasing. What is the domain going to be, you guys? All real numbers. That's going to be for some polynomials? No, all of them. Good. How about the range here?
All real.
All real numbers. Is that true for all polynomials? No. What polynomials are always going to have all real numbers? The odd ones. Odd degree. Anytime it has an odd degree for a polynomial, you're always going to have all real numbers for the range.